Part C tells us to find the percentage between 547 and 706. So what I've got here is 68% plus the 13.5%, which will give us 81.5%. Part D says that the company will replace bulbs that last less than 441 hours. So I've got to see where that lies. If I take 494 minus 53 again, that's right here. So we're looking at the percentage of bulbs that they will replace will be 0.15%. Part E says, what happens if we're looking at Chebyshevs where we don't know the shape and we want to know the percentage of bulbs that will lie within plus or minus 2.5 standard deviations? Chebyshev says 1 minus 1 over the standard deviations squared times 100, which gives us 84%. Now we need to find the percentage of bulbs that lies between 494 and 706. When we did that, it's 95% with the empirical rule, but they're asking us to use Chebyshevs. That's 2 standard deviations away. So again, we're going to do 1 minus 1 over 2 squared times 100%, and we will get 75%. Okay, number 6 tends to come from section 3.3. And it asked the travel time to work. The frequency distribution listed in the table represents the travel time to work in minutes for a random sample of 895 workers, adults. So 895 is my sample size. And instead of wasting time on the video, I entered the data. So here we have in list 1 the midpoints. Remember, when you have classes, you have to take the average. So if you look, I took the average of the lower class limits. So let me put the data in front of you. So I took the average of 0 and 10. That's 5. The average from 10 to 20, 20 to 30, 30 to 40. When you get down here, the next one should be 90, so the midpoint is going to be 85. And that's what I put in here. So I've got the midpoints. I've also listed the frequency. So now I do stat, calculate, one variable stat, list 1, comma, list 2, and it will take and find the means. Now part A is asking us to approximate the mean travel time. So for part A, the mean travel time is 37.5 minutes. Part B says approximate the standard deviation. Now it is a sample, so it's S that we're looking for. And as I look here, the S is 19.2 minutes. 19.2 minutes. And we're done with number 6. All right, we have 20 to 29-year-old females where the National Center for Health Statistics has given the mean weight 156.5 pounds with a standard deviation of 51.2 pounds. And the same thing for males between the ages of 20 to 29 as 183.4 pounds with a standard deviation of 40 pounds. And they're asking us who is relatively heavier. When we're comparing 2 different groups, we need to look at z-scores. So we're going to look to see who is relatively heavier. For the female who weighs 160 pounds, so I'm going to put female, and a z-score for a male. So the female weighs 160 pounds, or the male who weighs 185 pounds, minus the mean, divided by the standard deviation, minus the mean, divided by the standard deviation. And we'll see who's heavier. The larger z-score is going to be the heavier one. So remember, when you put this into your calculator, I don't know if you can see this. I'm going to put it in my calculator, clear. 160 minus 156.5 divided by 51.2 gives me a z-score of 0.068. Do the same thing with the boys. 185 minus 183.4 divided by 40, and I get 0.04. So the one who is relatively heavier is the female. All right, here's how we do weighted means. There is a student by the name of Michael that has just completed his first semester in college, and he received an A in his 5-hour calculus class, a B in his 4-hour chemistry class, an A in his 3-hour speech class, and a C in 3-hour psychology class. Assuming an A is 4 points, a B is 3 points, and a C is 2 points, calculate his grade point average. So this is a weighted mean. So what we're going to do is we're going to take and do 5 times 4 plus 4 times 3 plus 3 times 4 plus 3 times 2. So these are his points and these are his hours. So we're going to divide this by how many hours he took. And when we plug this into our calculator, we get 3.33, and that would be his GPA that semester. All right, in number 9, it's looking at box plots, and I wanted to show you how to analyze side-by-side box plots. This is a population density. It's the population per square kilometer of the 50 United States and the 15 countries in the European Union. And so they're asking us, is the USA or the European Union more densely populated? Now this is telling us that there are more people per square kilometer in Europe because of the larger numbers than there are in the USA. So it's Europe that is more densely populated. And it makes sense. Smaller acreage, more people. Does the USA or the European Union have more dispersion in the density, and why? Well, it looks like the dispersion is more within the European Union because it's more spread out than this one. We do have some outliers, though, when it comes to the US of A. Are there any outliers? And if so, approximate their values. Well, the outliers here is about 490. There's a few out here that we could name as well. And the shape is definitely skewed to the right because it is, the tail is going to the right. Number 11 says, explain percentiles. There's a 19-year-old female whose height is 67.1 inches, and she's in the 85th percentile. What that means is that she's taller than 85% of the people in the health statistics. Know how to explain that.